Today we are doing section 2.5, and this is about complex numbers. To understand complex numbers, let's start with some imaginary numbers from the imagination, evidently. So in the previous section, we talked about the discriminant. It's a part of the quadratic equation. So if you had just you had the quadratic equation and you had your number here, square root here, and this was the discriminant um, over, the 2ac or whatever it was. So, um, or 2a. Sorry. I am struggling. It's been a while since the hurricane, but we will get back into place. But that was the discriminant. And I'm sure you remember that. We went over that in depth. That if it's a negative number inside the discriminant or inside the square root, there's no real solution. So it's not a real number. So since it's not a real number, it's an imaginary number. And we can rewrite imaginary numbers with an I. I stands for imaginary. So I equals the square root of -1. Now, if I equals the square root of -1, does that mean we can rewrite this to pull out that square root of -1? Yeah, we can. So if we rewrite this, we can say the square root of 16 times the square root of -1, which we know the square root of -1 is actually just I now. So we rewrite it as square root of 16 I. Or since we know the square root of 16 is just 4, this is 4I. So this is an imaginary number, but we can have a solution for it. Excuse me. Alternatively, we can look at it this way: x squared plus 4 equals 0. And knowing how to solve this, I'll just walk through the steps. We move -4 on both sides. These go away. We have x squared equals -4. To get the squared out, we do a square root. And now we're saying that x is equal to the square root of -4, which we know is an imaginary number because it's the square root of a negative number. But we can rewrite this as x equals the square root of 4 times the square root of -1, or just x equals plus or minus 2I, because this turns into I because of this rule. And 4, square root of 4 is just 2. And plus or minus is what we always put instead of when we do the square root of a solution that was equal to 0. Um, so yes, plus or minus 2I. This is imaginary stuff. Imagination. Okay, so moving forward, imaginary numbers helps us understand complex numbers. To know, you have to have real numbers and imaginary numbers to have a complex number. Um, So let's look at some examples and then we'll talk about the complex numbers just a tad more. Um, so we have square root of -5. We want to change it to our imaginary numbers. Well, we know we can set it to square root of 5 times the square root of -1. Well, we know square root of -1 is I, so we have square root of 5 I. You can write it as I square root of 5, which may be a little easier to read. Let's start doing that. This is an I, believe it or not. Let's start doing that. Let's put the I in front of the square roots so it doesn't look like the I is under the square root. Um, Another example is square root of -36. Same thing there, just -36 times the square root of -1. Oh, this would be a positive now. And so since 36 is something that we can unsquare, we can just write 6I because the square root of 36 is 6 and the square root of -1 is I. So look at another one, square root of -24. It's the same deal. We do the same stuff. So I'm going to say to pull out this negative, let's just write down I. And now it's positive. And let's do the square root of 24, which there's no straight square root of 24, so we could just write it. And I just killed the whole thing. I told you what we should do. Let's put the I first. There. Now we can simplify the 24 by taking out some factors, but this is acceptable because it's still a square root of 24, no matter how you write it. All right. So back to complex numbers. This and get my little handy pencil. Okay. A complex number would be something like this. If I had 2 plus 3I. Well, that was odd. Oh, I know what's doing that. Okay. Yeah, 2 plus 3I is a complex number. That said, that means this 3I is the imaginary part and the 2 is the real part. Now we can't do anything else to this. This is the entire solution. So, having known that, if we write 4x plus 0I, the 0 times I is always 0, so it's left with just 4. This is a real solution. It's a real number. Alternatively, if we have 0 plus 7I, the 0 goes away because it's just 0, and you're left with 7I, which is an imaginary solution or imaginary number. So this is complex. This is a real number. This is an imaginary number. Okay. Moving forward, we have a chart that's going to be helpful using powers of I. So powers of I don't know if I want to rewrite this, not all of the chart anyway, but I itself, we know equals the square root of -1. So this is just I. I squared equals -1. I to the third is -I. I to the fourth is 1. And all of this is in your book. I forgot to mention that. And I to the 5th is just I. I to the 6th is just -1. I to the 7th is -I again. Huh, that. And I to the 8th, I see a pattern here, is just 1. Now, I want to show you this pattern. These are all I. These across here are -1. These are I. These are 1. So, what does that tell you? Does that tell you that multiples will come out the same? Power multiples will come out the same. Um, okay. So, I guess I could write the multiples, but it's in your book and you can see those there. And I think what I'm going to do is start some examples. And it's just simplify the powers of I. So I to the 12th. Now, I to the 12th can be simplified. Now, we're looking, if we look at the chart we had here, we see there's no 12 on here, right? But we want to solve this. How do we do that? Well, according to your chart, if we have I 4, oh, wow, write that in. 4n plus 1, that equals just I. If we have I 4n plus 2, and you see the pattern, I mean, we're getting the same pattern, -1. So I 4n plus 3, you guessed it, -I, and then I 4n, and these are powers, these are just raised to the power, plus 4 equals, you guessed it, just 1. So how do you find these? What does this really mean? Okay, so you know what? I'm going to copy this whole table because we're going to bring this back fun. So what does this mean for my I-12? Well, to solve this, you take the exponent, which is the 12, you divide it by 4, and you solve that. This is a 3. So, and there's no remainder. So what you're supposed to do, excuse me, is write this as no remainder. So I 0, because there's no remainder, equals just 1. Now, is I of 0 on here? Well, I don't specifically see I of 0, but I do see I. So where do they get the 1 at? Interesting. It says that's the solution, but there is no saved I of 0 memorized value. No, we'll see if we see that again. If we do, we'll know that, hey, I of 0 equals 1. Um, oh, interesting. All right. Let's try another one. Another example. I to the 23rd power. We take it, divide it by 4. Okay, so 4 going 23, 5 times. with the remainder of 3. Okay, do you want me to, you know what? Let me walk you through that because this, I guess it's been a while. Um, we're doing long division, and that's the only way you can get that remainder. 4 will go into 23 how many times? Okay. I just wrote it on the board. I mean, I literally just wrote it on the thing. It is 5. All right. So what's 4 times 5? Oh, that's 20. And that's 3. So that's where we got the 5. It equals 5 with a remainder of 3. Okay. So this remainder is what we take and write our I down with. So I with third equals, says right here in our chart, it is negative I. And there is your solution. Okay, let's do more. These are fun, quick, and easy. Shouldn't take very long to perform on your own. Just remember your chart and your long division. You'll be fine. That is a 50, believe it or not. So that's I to the 50. And so we're going to say, well, we're going to say 4 will go on to 50 how many times? Well, we know it'll go 1 time here. That gives me a 10. And how many times before going to 10? 2 times. And then we have a remainder of 2. So this remainder is what we write our I with. I2 equals negative 1. And there's our answer. Very easy, straightforward problems. Just to make sure you got it, let's go over another one. Excuse me. I9. Oh, that was horrible. Oh, it's even worse. 9. That's a little better. And see, in our chart, we don't have a 9, so we have to go through and do the division. So 4 will go into 9 twice, with the remainder of 1. And that's I1, which is this top one. This is really a 1. And this equals just I. That's your answer. So these are simplifying powers of imaginary numbers. And we have the handy-dandy chart and how to convert higher numbers to the normalized imaginary numbers. Now, we want to look at complex numbers. We want to be able to do things with complex numbers, reduce them down, get them down to like terms and things like that. Excuse me. So let's say we have something like this. 2 plus 5i plus 3 plus 4i. Now, we just, on this problem here, we just want to reduce and write it in the like terms. There's no way to really solve it because you can't solve an imaginary number. But we can write like terms. We have a 2 and a 3 that are like. So 2 plus 3 is what? Okay. And I'm writing a plus because everything says plus here. So 5 plus 4 is what? All right. 9i. And that's the answer. Okay, let's do another one. I'll just do it over here. 7 plus 2i. So, okay. Minus 10 plus 9i. Notice there's no multiplication here. Just doing addition. Easy peasy and subtraction. So we can rewrite this. Just maybe this makes it easier. We can rewrite this as this, and that's just fine. Or can did I make a mistake here? What do you think? So the parentheses were there for a reason, weren't they? That's why I did this. This is a huge mistake. You don't do that. You do this. You distribute that negative. So now we have negative 10. No change there. But negative times a positive is a negative. And that's what gives you that. So 7 minus 10 is a negative number. It is negative 3. And then we have 2 plus 2 minus 9. 2i minus 9i. Excuse me. Sorry. And that is minus 7i. Watch those negatives. Watch the distribution of negatives. This will get you every time. I'm telling you. You ask, why didn't we do it here? Well, I kind of did, but because everything was positive, it didn't really matter. You distributed positive in, it's still all just positive. Okay. Let's put this to test then. Now we need to multiply imaginary numbers. So let's say we had something like the square root of negative 12 times the square root of negative 18. Now, these are two imaginary numbers, just as imaginary as can be, that we're trying to solve. Now, what we could do is say, well, we know that negative square root of 1 is I. So let's take out this negative. I square root of 12 times I square root of 18. Now we pulled our negative out. Now, this would be an acceptable answer. I mean, it's not bad, but the book wants you to push full. It wants you to reduce these square roots. Now, how do you reduce the square roots? Well, we've done this. We've looked at it. Get your factors. So we know 2 times 6 is 12. Well, 6 will work, right? What do you mean 6 will work? Okay. What I mean is you're trying to find perfect squares. 6 is a perfect square, is it? Is 6 a perfect square? I'm asking you because I want you to think. So 6 is not a perfect square. Let's keep going. 3 times what is 12? 3 times 4. Is 4 a perfect square? We know 3 is not. Yes, 4 is a perfect square. So to rewrite this, you could say that, I'll just write it here, square root of 3 times the square root of 4, which is really square root of 3 times square root of 4 is actually 2. So to rewrite this guy, you could say 2i square root of 3. The 2 here, the I here, and the square root of 3 here. That's how we simplified this right here. Okay. Moving on. We have 18. Let's find the factors of 18. 2 times what is 18? It is 9. Is 9 a perfect square? Yes, it is, actually. So we have a square root of 2 times the square root of 3. Oh, I'm sorry. Square root of 9. I am just giving away the answer right and left. Square root of 9, and that actually turns into square root of 2 times 3. So we can rewrite this guy as 3i square root of 2. Now, um, we're going to finish this. So 2 times 3 is 6. I times I is I squared. And square root of 3 times the square root of 2 is the square root of 6. Because 2 times 3 is, as you know, 6. Now, we have a rule about this I squared. What's that rule? That rule is I squared equals -1. So if I squared equals -1, so we could just write this as -6 square root of 6. And that is our solution. Let's try another one. This is multiplying imaginary numbers again. Let's do the negative square root of -50 times square root of -10. There. So let's break this up. We know that we can pull out I for each one of these. That's a given. But we also want to pull out the factors. So let's start with 50. 50 here, 2, and 25. Is 25 a perfect square? I believe it is. 5 times 5. So this can be 2 times the square root of 5. All right, so we can rewrite this guy as we'll pull out the I. So we start with a negative here. So -2 I square root of 5. Oh, I must have wrote that wrong somehow. What did I do here? Don't be like me and write this backwards. Okay, so uh, here we go. Let me get the eraser tool or something. Okay, let's just start over. Let's start over. Negative the square. I don't know why I wrote this way. This is all wrong. It's the square root of 2 times 5 because 5 times 5, a square root of 25 is 5. So we're solving it there. So this is actually 5i square root of 2 times, excuse me, I square root of 10. Because 10 breaks into 2 and 5, then there's no perfect square, so you can't do anything with it. Now, let's keep going with this one. This would be -5 times 1, which will be -5. I times I, which is I squared. And then square root of 2 times square root of 10, which is just the square root of 20. And so we know from this chart that I squared is -1. So since I squared is -1 and there's a negative here, a negative times a negative is just a positive. So we're left with 5 square root of 20. Excuse me. And we could simplify this further, taking 20, 2 times 10. That don't seem right, does it? Maybe. But we could do it further and we'd eventually get a number that would work. But this is acceptable. We're going to move on. All right. Now let's look at multiplying complex numbers. So given a number like 8 plus 7, so we have one complex number, times 6 plus 2i. And we have two complex numbers. Now, the parentheses mean a lot, and if this looks like what you're thinking it looks like, it is. We just use the FOIL method to solve this. So the FOIL method, we do 8 times 6. And what is 8 times 6? Do we know? Do we have to burden ourselves with these every time? It is, where do I write this? Let's do it right here. 48. Okay. So we did that one, and then this one to this one. 8 times 2 should be plus 16i. And then this one would be 7 times 6, which is what? Okay, so we got plus 42. I. And then we do this one, which is 7 times 2, which is 14. And we have two i's, which is I squared. Okay. So we need to simplify, combine like terms. So we know from combining like terms that we can combine these two inner ones. So let's do that. So this would be 48 plus 6, 7, 8. 58 looks like I plus 14i squared. Now we know that I squared from this chart right here is -1. So -1 will replace this 14i. I mean, this I squared right here, which way we would write it out like this and just change the sign to negative. So now we have 48 plus 58i minus 14. Now we have two more like terms, 48 minus 14. So 48 minus 14 is what? Okay, so we have 34 plus 58i. And at this point, this is reduced as much as you can, and that is your complex number solution. All right. Okay. So now, give you another one. This is multiplying. So we have -5, 12 minus 3i. And all we have to do here is distribute this guy into both. So we have 5, sorry, yeah, negative 5 times 12, which is negative 60. And then we have negative 5 times negative 3i, which now turns into plus, and that's 15i. And that's the best you can do. You're done right there. Let's do another one. This one is 23i, and we have 3 plus 2i. 3 plus 2i. Now, this will give you 23i times 3, which is 69i, plus 23i times 2, which is just 46i squared. So we have two i's here. Now, according to our handy dandy chart, this I squared will be a negative 1. So this will change to a negative 1. So we're left with 69i minus 46. And that is the solution. Okay. Now, we're going to be dividing complex numbers next. It's similar to the rationalizing the denominator that we did earlier. Um, you'll see what we're doing. I mean, it'll become clear here. Okay, so they give something like this: 4 plus 6i divided by 2, and they want us to solve it. Well, we can rewrite this as 4 over 2 plus 6i over 2. So that means we can get rid of this part and make it just a 2. 2 plus, and then 2 will go into 6, but it's 6i. Can I do that? Yeah, we can. So 6, it'll be 3 times. And I there. Because I was carried around with it. All right. This will be the solution. Excuse me. And now let's do a 16 minus 12i over 4i. This, we can rewrite it if we wanted to as like we did above, or we can move some i's out from it and do it that way. Um, so removing the I from the denominator would be your goal, because if you can remove the I from the denominator, then you can solve this as a regular number with not being in division. So to remove it from the denominator, we're going to do the same thing to the bottom as we do the top, and multiply by I. So you're not really adding anything to the equation. Well, you are, but you're not really removing it either. So it's the same. It's I over I, which is really just 1. And this will give you, so the imagine this is like this, and you're distributing into each one. So this will give you 16i minus 12i squared all over 4i squared. Now we can take, and if we want to, rewrite it or get rid of the powers, since we know that, okay, this I squared and this I squared will get rid of each other. And you could be left with 16I minus 12 all over 4. Now you get this to be 16I over 4 minus 12 over 4. And this would be, oh, it's a negative. There's a negative 4? No, because I squared is a negative. Oh, that's how it. Okay, well, that's interesting. Yeah, okay. So, because I'm rusty, do this correctly, I want to start over. Let's start over. Would you like to start over? It's the same numbers. It's just I didn't teach you correctly. I should stop looking at the book. Oof, get you messed up. All right. This is where we were. If we look at our handy dandy chart, we'll see that I squared is negative 1. So let's place negative 1 in each one of these. So that would be 16I plus 12. And this would be just negative 4. Now we can rewrite this as 16I over negative 4 plus 12 over negative 4, which would give you negative 4I plus, I'm sorry, not really plus, negative, because this negative on the 4, 3. And this is your real number. I mean, your imaginary, your complex number solution, which complex numbers. Okay. There is a quadratic equations. Remember that quadratic equations that we did? So we can do those with complex solutions. With complex solutions, you would just use the I to solve for X. And I would be a part of your equation because you would have a negative of a square root. So we're back to that. Back to identification. So to identify an imaginary number, it is the negative square root. It's a square root that has a negative. So let's look at one. We have x squared, and this is stuff that we've done before, plus 8 equals 0. So we're going to write the equation in standard form, already been done for us. We're going to solve by any method that we know possible. So what method do we know how to solve this with? What have we done in the past? Let's do the little, okay, so let's do the way we've been doing. So we have a 1 here. 8 times 1 is just 8. So we now need to have multiples of 8 or factors that add up to negative 4. So 2 times 4. I don't think that's right because 4 might, yeah, that wouldn't work out. So are there any other multiples that would make it? Well, I don't know if there is or not. So the answer is there is no way to do it this way. Well, why is that? Well, because I believe this solution is probably going to be a complex number. It's not going to have a real solution. So we need to solve this using the quadratic equation. And we just looked over that, so it'd be good practice. The quadratic equation. let's look at it. Negative b plus or minus the square root of b squared. This is not b squared. What would it be? Yeah, it is b squared. B squared minus 4ac all over the little 2a. So we know that a is 1. So a equals 1. We know that b equals negative 4 and c equals 8. So let's plug that in. So b is negative 4. So we're at 4 here, plus or minus the square root of b squared. Well, negative 4 squared is what? It is just 16. Minus 4 times a, which is 1. So we won't write it down. And c, which is 8. So 4 times 8. And what is 4 times 8? We're just going to start solving on the fly. And that is 32. So we should erase this part and write 32 because that's what that's going to be. And then we could probably just go further and say, okay, well, if this is going to be 32, 16 minus 32 is just 16. Rewrite that as just negative 16, which confirms our suspicion that this is going to be an imaginary number, because any negative under a square root is going to be an imaginary number. All right. So then let's just solve for x, or solve, well, we're not really solving for, well, yeah, we are. This is x equals, so just like that. All right, so let's try. Oh, wait, I didn't write down. I just wrote. I'm missing a lot to do. A equals 1, so we'll just write 2 there. All right, excuse me. So 2. Well, okay. You know what? Let's rewrite this as. Well, 2 will go into 4. Um. hmm, How should I teach you to do this? Because okay, okay. Because we could do this. We could say 4 over 2, right? Plus or minus the square root of negative 16 over 2. If we do it this way, we can say, well, 2 will turn into 2 or 4 will turn into 2, plus or minus, and the negative 16 will just turn into the square root of 16 I. So if we have I square root of 16, what's the square root of 16? Do we have a square root of 16? Is it a perfect square? All right. So it is, isn't it? Or is it? Hmm. So if I take my calculator, I put 16 in, and I put square root, it says it's 4. Well, that's because 4 times 4 is what? 16. All right. So let's rewrite this as 4i over 2, which we can rewrite as 2i. So the answer is 2 plus or minus 2i. And that's what we got there. This bit right here was the tricky bit. I think maybe for you. And if you don't understand it, I can go over it again, but um, let's do another example. So maybe that'll help you. maybe one more example. Okay, this one is 6x squared minus 12x plus 12 equals 0. So how can we solve this one? Well, we know we're probably dealing with complex numbers again. So let's just skip to let's just skip to that equation, quadratic equation. So negative b plus or minus the square root of b squared minus 4ac all over the little 2a. Okay, let's identify our numbers. 6 is a, negative 12 is b, and 12 is c. Let's plug them in. So b is negative 12. So, and this is negative, so we just write down 12 plus or minus the square root of negative 12. What's the square root of 12? I mean, I'm sorry, not square root of the power of 12. Okay. Anyway, I'm 144. Because negative 12 is negative, is negative times negative, which makes it positive. Minus 4ac. All right, 4 times a, which is 6, times c, which is 12. You just do that in your calculator real quick, which is 4 times 6 times 12, which is 288. Now we can say, well, 288 minus 144 is just 144, but it'll be in the negative because the bigger number is negative here. So we can rewrite this as negative 144. And look, it's going to be imaginary. And then the bottom is 2 times a, which is 6. 2 times 6 is 12. And there we are. Now, we can rewrite this as 12 over 12 plus or minus the square root of negative 144 all over 12. We can rewrite this here as just this section as I 144. And what's the square root of 144? Well, it's just 12. So this is over 12 still. So this will be 12i over 12, which is essentially just I. So 12 over 12 is 1. So this solution is just plus or minus I. We could write it 1 plus or minus I to help confusion because 12 over 12 is 1. That's where we got that. That's where this came from. And the I came from all this, and that's where that came from there. And the plus or minus came from there. Okay. Well, it is time to give you your homework. And a lot of these will go quick as you look at your charts. And they'll have you solve some stuff. I think what I want you to do is 1 through 36, blue box. Yeah, 2.5. 1 through 36 in blue box. Oh my goodness. Okay. And then I want you to work on 39 and 40. Those will be your quadratic equation ones. Just two of them that you'll need to work out. All right. Good luck.